welcome back. I'm hoping you were able to join us for the previous demonstrations. If not, welcome. My name's Bill Plord, and on behalf of Southern States Machinery, Mid-Atlantic Machinery, Northeast Machinery Sales, we welcome you to eFAB Expo Day 2. This week, I think you all know we would have probably been in Las Vegas at our FabTech show, which has been canceled. So it would have been nice to see everybody and have some of those big dinners we've had in the past. But the good news is we wake up today probably feeling better than we would have felt and probably more money in our pocket from not going to the casinos. So good news with that. Our next builder visit will be BendTech. Ron Dabble in Osceola, Washington is here with us, and he'll be demonstrating the Dragon A400 CNC plasma cutting machine for tube, pipe, angle, channel. This is a really exceptional piece of equipment that is very affordable to the smaller job shops and just so versatile. We each of our facilities has one for demonstration, so we'd love to show it to you. But with that, I'll hand it off to Ron. Ron, it's all yours.
All right. Hey, thank you, Bill, and thank you, everyone, for joining us on this presentation for our Dragon machine. We're not quite as far out west as Bill said with Washington. We're actually Wisconsin, just north of Minneapolis, St. Paul, not to give you too hard of a time, Bill. But we're north of the Twin Cities, just on the Wisconsin side of the border. So welcome. We're excited to show you what we can do with our tube Dragon here. We basically concentrate on small to medium tubing. Handrail's been a huge market for us, motorsports, all kinds of manufacturing for guys that are basically in the size of tubing that we're doing. And I want to show you a few parts that we can cut with the machine and talk about the parameters of what we can do for you. So certainly the sizes, like Bill mentioned, we can do square, round, rectangle. You can see here if you need to cut slots, holes, miters, copes, all that's possible on the Dragon. Not a problem to be able to do. We've recently, a year ago, added angle and channel capabilities. So on the angle and channel, you can do any angle and channel that is going to be 4x4. It can fit into a 4x4 box, I guess, is the easiest way to put it. So you can cut angles, again, holes, slots, a couple different examples here of what we've done on our Dragon machine here. Here's an example of some channel that you can see. So again, any channel angle that fits in a 4x4 box, we can process through the Dragon. On the round, we can go up to a 6-inch round and down to basically a 3/4 inch round are the parameters. So there again, you can see the plasma cutting on an example of a larger piece. One of the also neat features we do is we can draw the weldment fit-ups on a tube. So if you have an assembly and you want to know where that fits up, we've got a marker station and an engraver station. Either way, that allows you to put that together. So here's an example of if you had someone out there needing to weld this together, all those parts are nicely drawn out on where that fits up. And there's also something we do called slot and tab. So not only if you want to just mark, but say you want to really fixture in where that lands, we can do a tab and a slot. So your weld fitment then is just, that easy. You put that together, you know exactly where everything should land. So saves you a ton of time on the setup of these parts and pieces. And if you guys have put together handrail and other assemblies, you know what I'm talking about. Here's an example of some 4x4. So in our square, we can do up to 4x4 in material size. And again, miter cuts, holes, in any kind of geometry you want to cut out, not a problem for the Dragon. We also, I want to talk about one thing we do. We've been doing tube software for over 20 years. And one thing we can do is calibrate to your bender. So if you're bending tube, you can bring a bent piece of tubing into our software And then our machine can mark the bend location here and tell you bend 1 is 45 degrees, can also calculate spring back. So when you take a piece of tubing, you can get all the cutting done on it, holes, again, miters, copes. The operator then can take that piece of tubing, line this up in your bender, calibrate it exclusively to your bender, and go ahead and bend that piece of tubing. So that's something pretty unique to our machine compared to anything else in the marketplace. We also can do some other things besides mild steel with our machine. We do have a coolant system, and this allows us to cut aluminum without it getting too hot, so you can get some nice cuts by running coolant through the tube, just recirculating it, and then being able to, again, plasma cut, where if you didn't do that, you would just not get this nice edge. You'd have issues inside with dross, and just it would not be very plasma friendly. Here's a piece of angle. Obviously, we don't use coolant for that, but the plasma is not hitting the backside, so that shows you some things on aluminum angle that we do. And then another popular thing is stainless. So again, with running a coolant through stainless, we're able to plasma cut that and get a very nice result. You're still going to get a little bit of a plasma edge. If you run nitrogen, that does help that as well. So, but we do have quite a few Dragon customers cutting stainless. And then for fun, we do have a marketing department that likes to have a little fun once in a while. So you can take a DXF design and cut this out with our Dragon machine. So we've done some different examples here. We've cut a tube and unfolded it, which is kind of a fun piece we take to trade shows. And because it's Thanksgiving, we thought or soon to be Thanksgiving, we thought we'd show you, happy Thanksgiving to everybody a little bit early. This was all cut out on the Dragon machine as well. So that kind of gives you an idea of what we can process with the machine. What I'd like to do is go over the machine, kind of show you the components, how it works, and talk a little bit about that. So in our shop here, we have a water tray system set up. This is for our coolant system, and there's 3 5-foot trays that go out. So if you have longer parts, it's going to capture the water, come down into a sump, and then it's going to go back to a hose reel that's retractable, and that's just going to be your system of recirculating water through the piece if you want to use the water system. But let's talk about our head. We have Thompson actuators that go up and down, left and right, and we have, again, a marker station. So you can put a marker in here, again, mark bend locations, part numbers. We also have an air engraver here, and this, again, allows you to mark the tube, however you need. If you want, again, part names, numbers, or bend locations, just another way to mark. Of course, we have our mechanized plasma torch here. We do recommend Hypertherm, but you can use any plasma mechanized torch will work with our system, but we can provide a Hypertherm. And typically, we would recommend for an average steel shop probably a PowerMax 65. If you're doing some heavier duty stainless or aluminum, you may want to jump to an 85, but 65 is kind of our workhorse. And then we also have a little laser lineup light here, and this allows the operator to see where the end of the tube needs to be when they load the tube up. So our front gate here, we'll talk just a minute about this. This is 2 sets of rollers here, left and right and up and down. And the operator, when they change material, you just need to change it 1 time per that size of material. And our rollers can, again, accommodate all those different types of tubing and angle and channel that we showed you on here. The angle and channel upgrade to the machine is actually a gear here and a motor, and this actually rotates the gate with the chuck as the material is being processed through. And that eliminates any spring that an angle or channel might have compared to a tube. So that is one of the machine differences. Our standard machine that does square, round, and rectangle does not have a motorized gate. So just wanted to point that out. So that's basically the head of the machine. We'll take you to the back here. The machine is a full 24-foot bed length, so you can put a full 24-foot tube on the machine and load it up. This is our hose reel. Again, if you use the water system, this is just a retractable system that's going to go into a plug in the end of the tube, and you're just recirculating the water through the machine. If we come up here to the chuck trolley, what we have here is a 4-jaw chuck, and this allows you again to chuck in any of those materials as the operator needs to load it. This is a belt drive system, so with the to move the material in and out as it's being processed. And again, this is a full CNC run through our Dragon software. We have our control box down here that is manufactured by us. I guess one of the things I want to point out, this is completely made in the US, including our software, which we've done again for 20 years. So everything gets assembled here, put together, calibrated, and then shipped to our customers. Right here, we have a lifter station about 6 feet back from the head of the machine. So if you do have a full 20-foot stick, and maybe it's thinner wall, so it's going to sag a little bit from the chuck to the front gate, this lifter station will come up to the correct height. The operator then will load the material, and this keeps the material going straight through the gate to make sure, again, our precision of our cuts are going to be as accurate as possible. We can hold a plus or minus 10 thousandths on our machine when everything is dialed in. Now, if you're processing square or rectangle, this lifter is going to go up and down as that gets rotated to follow the material. Obviously, with round, it's just going to stay there. When the chuck trolley comes close enough, it's going to automatically swing out of the way, and you'll finish processing your tubes on that. So that is a little bit about that. That's basically it for the machine. What I'd like to do is hand this over to my tech, Jared, who will be screen sharing the BendTech software, and we will go through a little bit of our software capabilities. When you buy a machine, you get a full software package. You can draw in BendTech. You can import CAD files from BendTech. We do have a direct interface with Tekla and SDS2. And any other CAD, we can bring in step models, so we can bring in single parts or assemblies into our software. And then we also have a great feature. You can design a single part or assembly in BendTech. So Jared's going to show you a couple of the things in our software, kind of walk you through how easy it is getting the part nested. We're actually going to load a piece of material, cut a sample for you guys, and then kind of go from there. So Jared, I will have you take it over here on the software side.
All right. First thing I'll show you is, so this is the CAM software that we have. The couple different options that you have in here. Number one would be creating a bent part, 2 straight part, 3 quick nest, and then 4 would be import. These 2 here would be individual pieces as you draw them. So before we do that, I'll show you the tube library. You'll essentially create your material library from anything that you guys use frequently or anything that you have on hand. Other than the name, the only requirements are your material wall thickness and then OD of material. And then it has other settings as far as the pierce height and your cutting height and that stuff. And then it also has your feed rate of how fast you're going to move with the machine. So once you have any of your materials set up, I'll just show you the straight part here. So right here would be a part name if you have a number that you're applying to a part or anything like that. So I'll just go with P23. And then right here you're looking at your tube length. So that's meaning the length of the part that you're actually trying to cut. So I'll go with 6 inches for that. The second tab up here is going to be cutting. That's meaning any end cuts that it's applying. So if I hit add the first time, it's going to automatically do a cope. Second time, it'll do the same to the opposite end. So I have a cope set to 90 degrees on either end of this material. To change any of that, like between cope and notch, I can select that and go back and forth between a cope and a miter. And then same with the other here. If I want to change the rotation, I can click on that and and say I need a 58-degree angle rather than a 30-degree or a 90-degree angle. Same with the copes. If it's not in the correct rotation, I would change that and say this needs to be 180 degrees rotated from the other, and that would be the cope on either end 58 degrees. If I want to view that, I can click on this wireframe or this shaded display, and that'll show me the actual fit up of those pieces. The dimension style that we use as a default is to centerline. So centerline of whatever adjoining piece that you're using, you have the ability to change that right here. So you can go between center, you can do inside of cut or outside of cut. So overall part length or center line or inside of cut length. So not including the copes. And that's purely based on whatever the shop uses as their dimension style for their prints. If it's the case where the ends are not coping to the same size material, I can go up here to this material drop down and choose a different size. So if my 1.5 inches was going to cope to 1.25 inches rather than 1.5 inches, I can change that so that it fits that material that it's coping to rather than coping to the exact size that you're using. And you also have the ability to do a custom profile as well. So if it's a material that you don't have in your material library, you would just set those material parameters, and then you would be able to cut out that piece against the other size that you're using. The offset is just for cuts that if they were not on center. So if I take one of these and move them off center 1/2 inch, it'll be an off-centered cope rather than on center. Go back there. So the second tab here is going to be your holes. If I hit add, it's going to ask you what shape of hole that you want to do. We have the ability to do a round, square, rectangle, oval, ellipse, and triangle hole. So it's up to you on which hole shape that you want to use. So I'll start with a round hole. Up here you have the width of the hole, so that's going to be your OD, the diameter of your hole, so 1/2 inch. The distance is going to be from your black dimension line that you're seeing here where you're at. So to actually contact material, I'm going to go to 1.5 inches. And then right here I have a create opposite hole. What that does is it creates a hole 180 degrees from the original. That's an identical hole. If that came in at an angle, so the same as my copes are going, so I'd go with 32 degrees. And now that's not only going to elongate the one hole so that I would have clearance for a picket or something like that, but it's also going to offset this hole here so that they're not directly below each other, so they're at the same angle as what those copes would be. And then you can rotate that around as well. So if I choose 90 degrees, it's going to end up on the other side of the material rather than the original side. Default is going to be to measure from the start of your part. You can change that to end of part as well if you'd rather. And then right here you have the ability to copy. So if you choose copy, it's going to be the identical hole. All you need to change is where that distance from the start of your part or end of your part would be. And then the grid function is going to be how many holes that you're trying to create, and then what's the spacing in between those holes, and it'll go out and space those holes out so that you have that number of holes. So I'll add another hole here just so we have a few more. So from here, if say this was my finished part, what I would do is go into nest part. And what that's going to do for me is pull up the actual program that I will run. So right here, you would have your stock length of material, which is a default number if you choose that to be. Otherwise, it can be just set to 0, and you would just enter the length of whatever the actual material that you have available to you is. 1/2 is the length of the stick that I have over here. So a couple different ways to nest in here. If I go in here, I have a button here that'll just ask you how many do you want to add. Hit enter, and it'll choose that number for you to continue. The blue here is going to be how many. It's going to fill up as many as possible on your stick of material. So that I can cut 17 out of the available material that I have. And then this subtract here is going to be the how many do you want to get rid of? And it will take that many away as well. So before we actually cut anything, I'm going to show you a couple other software functions. Let's see. So I'll show you the CAD program that we have. So we have a full CAD program as well with a bunch of different options of things that you're able to do. Assembly is the most common one. So the that would be drawing of anything that you're trying to do, and it's in a 3D space. There's multiple different templates for things. So if I select this, this is going to be a number based off of how many bends are on that part, and I can choose between any of those and select what shape of part. So 5 and 6 are going to look like similar to some of your handrail parts. 1 and 2 are going to be like small hoops and stuff like that. And then I also have, I can draw basically the same as what I did in the cam side. I can draw individual parts in here. I can use XYZ coordinates as my drawing if that's your preference. And then I have a couple other different template styles. So AP would be armor pack, which means any bumpers. It has tire carriers, roof racks, rock sliders, and stuff like that. So there are a few in here for like your razors, or a couple for like a Maverick and stuff like that. The others would be just generic models and you have the ability to change all of these to fit whatever that you're trying to put it on. So you can change dimensions. Let me open one up here for you. So I'd choose material and die. And then right here, as you can see, I can change any of my dimensions to fit whatever I would be trying to put that on. So if it's not a Maverick, but you like the style of it or something like that, you could have the ability to change that and modify it to whatever vehicle. Close that. Okay. So this is just an assembly that I drew quick. So I'll show you the transfer in between CAD and CAM. So once it's drawn, I would go to transfer and I would choose drag and CAM. And then that's going to come up in my CAD or CAM side of the software. This is all the parts that it's included in that. So I would go and nest that, and create a nest out of it. So I will go as my default is a 240-inch stick. The parts are all under this parts list. So you have your first, the main bar, and then your mid rails and your posts as well. So the other option for nesting is called auto nest. So if I set this to 0 and I hit that auto nest button, that's going to automatically apply all of those parts to my different lengths, and it's going to fill up the number of sticks that you need to cut it. So we need almost 2 full sticks to be able to cut out all those parts. So it's going to do that, and if you have too many, say you had 8 sticks listed in there but you only needed 2, it'll retract those to get rid of them, and you don't have to use the 2. So I'll go ahead and make this back into my nest, and then we'll go ahead and cut this out. And right here, I would just hit run project. That's going to come up with my machine control window. The first time I hit start, it's going to go to my load position. And then the second time you hit start, it continues and cuts that out. So let me stop sharing this quick. Be back. So I'll go ahead and load that piece of material. So with that in there, you'll have to tighten up your gate as well. So that's just a 1/4 inch Allen hex head. Basically tighten it down until it's touching both sides of material and you're not trying to crank down or squeeze down on it too much. Then in order to reach the other side, I need to rotate that. Like Ron said, there's only 2 sides, so I would close down on this one.
And once you set a material, it's good until you need to change material size too, just to reiterate that. So.
Let me check the temperature real quick. And with the coolant system that you're using, you really don't have to worry about touching it. It's pretty cold to the touch when you're using that. Without that, you'll need to, we usually keep a little bit of water in the bottom of that bin so that parts can be cooled off. So your two copes right there, both 58 degrees opposite of each other. And then you have your pass-through circle hole there. And then you have the pass-through square hole right there with, that's a number 3, so that would be the height of the letter is a 1/4 inch right there without changing it. And then you also have that last hole that we did right there. And if you want to see how that fits up, typically just set it on here. So that would be the fit up that you're looking at.
And the software does normalize a cope. So if you guys get a design in a CAD and it's got a knifed edge, our software looks at the thickness of the material and adjusts that for that automatically. So, but yeah, I think that pretty much wraps up what we had to say initially. So I will hand this back over to Mid-Atlantic and go from there.
Thanks so much, Ron. That was great. And I did just want to say quickly to anybody that is watching that had some technical issues, we will send out a link of this recording. So we are sorry about that and thank you for your patience. But we will get to questions now. Ron, the first question we have is the chuck driven by a timing belt?
So the chuck itself, the rotation wise, is driven by a gear that's attached to a motor. We have a little pinion gear and then a larger gear that drives the actual rotation of the chuck. The back and forth movement of that chuck is, yes, driven by a belt. If you want to take a look at it, that belt is set right here. So it goes up into that chuck trolley. There's 2 idler rollers, and then it rolls around a gear that's attached to an X motor that drives back and forth.
Thank you so much. The next question we have is the level support station automated in a post processor, or is that a function that must be manually programmed?
So we calibrate all the machines here. So anything that you add to that material library is pre-programmed in there. So you should not have to adjust that lifter pretty much at all. There may be some cases where you have minor adjustments to height, or if the lifter's coming up too far, things like that, that you want to adjust. But for the most part, it is calibrated and should function to every material that you add to your library.
Yeah, when you change materials, it'll change, it'll know what height it is. So if you're going from 6-inch tube to 2-inch, it'll automatically make that adjustment.
Next question we have is there a minimum part length limitation?
Yeah, so when we do chuck into a material into the chuck and it goes, it'll go all the way into the head of the machine, but from where it can hold it here to where the cutting is about 11 inches, and that's calibrated with the machine. Now, if you did need a full length stick, we do have a flip function where you can basically maximize all the material. It'll cut one end, make a mark, and then you can unchuck it, realign that mark with the laser, and cut the other end. So technically, you could cut a 24-foot piece with a cope on each end. Most of our hand drill shops are burning through and just leaving that 11-inch remnant because of the time, but it is available if people want to do that.
Great. Okay, so next we have, how would I import a weldment assembly from SolidWorks to cut in this machine?
So that's imported as a step file. There's the import function that we have. You would choose the import option. As soon as you save that as a step file, you'd be able to open that up. And basically what you would see is the same as this handrail assembly that I transferred over. So if I send that back over here, give it a sec to open. So you would see the same message, and you have the option to transfer between designer or a nest. Designer would be only for if you have changes to make to the parts. The nest would be just to nest those parts and cut them out.
Okay, thank you. Here we have, are these stepper motors or servo motors?
So we do use stepper motors. They're US made. And one of the reasons we do use that is because the load changes when you put a full tube in and as it processes, where servos would have to be tuned, and there's some issues, or can be some issues there since the load does change. So we've been using steppers now for the 5 years since we've had Dragon. Good quality motors, and yeah, they do the job wonderfully. We don't have any issues with them.
Okay, thank you. Next is, what is the process for labeling each part?
So Jared, if you were to import, it will put a number on those parts, right? Or if it's drawn up with the label, you can choose that action to scribe or write on the part. So we do have an auto labeling, or again, if the part has a label with it, we can, again, write that on the part depending on how you want to name that. But it's just a function of whether you want to cut, scribe, or mark on the tube, basically.
Okay, here we have, do you have acceleration numbers for your machine?
Yeah, we do have acceleration, so most of those axes are set differently, as well as your rotation. We base off material size and thickness, so that will vary somewhat based on material size. The X acceleration is anywhere between 7 to 10 for acceleration. Actual feed rate being anywhere from, you can go pretty much as low as you want, but from typical would be 60 inches a minute all the way up to around 100 inches a minute.
Okay, great. Well, Ron and Jared, thank you so much for being here with us today. Unfortunately, that is all the time we have for questions. If we did not get to your question, feel free to sign up for a one-on-one session in the link that will be emailed to you after this, with the recording of the session as well. If you could stay tuned for our next session with InspecVision at 1 p.m., we will see you then. And again, thank you for coming, and thanks Ron and Jared for an excellent presentation.
Thanks for having us. We appreciate it.